Alright, so if I'm going to find the area of the region, first thing I need is at least a decent sketch of the curves. Alright? Y equals x squared is the easy one. So we do that first. I think x equals negative 3. Uno, dos, 3. And x equals 3. Wow, is that out of scale? Oh well. So everybody, I think we know that these points of intersection happen at 9. Positive 9, right? Because 3 squared and negative 3 squared are both 9. So I shouldn't dot those. Those should be solid lines. I don't know why I made them dotted there. Alright, now the hard one. 8 minus x squared. If this is 9, 8 is here. 8 minus x squared. When you put in 0 for, or so square root of 8. Alright. We're going to end up with some regions. Now, problem here is, where are the regions? I think you guys are trying, I would guess, usually what students try to do is they try to shade somewhere in here. Is that where the region's going to be pinned this time? No. Where's the region going to be pinned this time? I think the region's going to be pinned right here. You agree? I don't know. I might need a little better picture here. All right? But I think the region pinned between these curves is going to be over here someplace. You know, and I should make my...
I'm so confused which line you're spinning it around.
I'm not spinning.
Oh.
Sketch the region and find the area.
I'm so used to your spinning it.
Yep. So the spinning is going to be find the volume. This is find the area. So guys, I'm going to grab my calculator for a second. And I'm recording this. And I'm going to put up... Ooh, wow. I'm going to put that in my calculator because I really want to see this region. Alright, and I want it to be correct. Clear all my old functions from other classes. And I put in, what, 8 minus x squared? X squared. Alright, and I'm not going to put in... I'm not really good with these calculators, guys.
Why are you using those areas? Like,
on the outside?
Yeah.
Alright. And if I go to the window, then we're going to go from what? You want to go from negative 3 to 3? We'll make or negative 4 to 4. We'll go that route, okay? And I'm going to make the y a little bigger. I know I got to be at least, we're going to go negative 5 to, say, 10. I'll show you why here, because when I graph this, and I'm going to capture this right now. All right, I'm going to capture this right now. Everybody, there's the two curves. I'm going to put in x equals negative 3, and I'm going to put in x equals negative 3. Everybody, when you say these curves, where are the areas pinned in these curves? The area is not between, the region between the curves that were all four of these curves touch is right there. All right?
But those lines, they restrict them all from touching. I'm just so confused.
Why are you confused? What part is it?
Like the 3 and the negative 3, like why do those like usually you found the area where like all the curves slash lines are touching.
Yeah.
And obviously there's not a spot where they're all touching. Those lines are like 6 away from each other.
I agree. So there's not one region.
I'm just so confused why that counts.
Well, let me ask you the question. Do you agree that this is the area where these three curves touch?
Yeah.
All right, and over here is the region where those three touch.
Yeah.
And then the only argument would be, is this a piece of candy? You guys, and do we include the area here, right? All right, it's like a TIE fighter for Star Wars. All right.
But I still don't. That doesn't answer my question. I feel like you're pulling a Collins on me and answering a completely different question.
No, that's not my intent. Here's the thing. You have to find the area between the curves. And
Yeah.
do you agree that two parabolas obviously cross in the middle to make that little semicircle, right? Or that circle, that oval.
Yeah.
Well, the x equals 3 and x equals negative 3 have some area enclosed too, which is out here. I don't get to decide. I guess is my opinion, is my point. You don't get to decide which area.
Oh, so it doesn't matter that they're not touching. It's just like what, like the area.
Yeah, that all 4 of these curves make that area.
So it does not matter if they cross.
Right, exactly. And do you?
That's where I was going off.
Okay. Does that make more sense now?
Yeah.
Now, the real problem here with this, guys, is that the upper and lower curves change. Think about it. When we start, you guys, first of all, do we agree these are all even functions? Yes. So do we agree we definitely want to start our integral from 0 and go to 3? But I'm going to have to find this point of intersection between the two parabolas. It's going to be x squared equals 4, so it's going to be 2. Because if I go back to these two functions, the parabolas, do you agree y equals y? So do you agree x squared equals 8 minus x squared? And then you just do 2x squared equals 8, divide by 2x squared equals 4. So x is plus or minus 2. So that's the point of intersection. Because I don't want to have to set up tons of integrals here. I don't want to, because if I try to do from negative 3 to 3, I want you to notice, if I make it yellow, that the upper curve here becomes the lower curve here, becomes the upper curve there. If I go negative 3 to 3, I'm going to have 3 integrals. At the very least, by starting at 0, I get to have this be the upper curve for a bit, and then what happens? It switches, and then the other parabola becomes the upper curve. All right, so we want to find the area of this tie wing fighter. I'm going to keep it nerdy, all right? All right, or the piece of candy, all right? And I got these x. So that's the area there. So I'm going to write the integral. I'm going to erase this problem solving. Area is always the same, guys. Area is always integral from a to b of the upper curve minus the lower curve. That's yu minus yl dx. All right, so we always find the area just doing that. So in this case, does everybody see? This is the hard part of these problems. That's why I like to do a bunch of them. Do you guys see that it goes 0 to 2 first? And the upper curve initially is 8 minus x squared, right? And this is where our pre-calculus really pays off, us understanding curves. 8 minus x squared. What's the lower curve right now in that 0 to 2 area? X squared. That's dx. Plus, and then the classic, I'm going to go 2 lines. I got to go 2 to 3 now. Do you guys agree? And now the upper curve changes. It goes to the parabola minus the regular, the Mulder function parabola minus the flipped, shifted up parabola dx. And everybody, there it is. That's going to give us the area. All right? Now, I'm actually going to do this out now and finish it and get us an answer. I want to know the answer. Now, I got one mistake. I forgot to do one thing at the very beginning of all this. What's this really giving me the area of? Half of it. To really be, I really should have a multiply by 2 out here. Do you guys agree? I really should not, whoops. There, I can just make it fit. I really shouldn't count on my memory to remember to multiply by 2. And you shouldn't either, okay? Math teachers, especially calculus teachers, they always want this setup. They want, and there it is. So if I said set up but do not evaluate an integral, boom, you'd be done. This would be a step. Yeah, and there will be a lot of those, because I think that's a pretty big part. But if I go 100%, I'm going to go down the page. All right? So now I'm going to start integrating. I'm going to leave the 2 as a green. All right? We'll see if I can make this work. First thing I'm going to do is I'm going to try to simplify these. You guys see it's 8 minus 2x squared dx when you combine like terms, plus 2 to 3, 2x squared minus 8 dx. I distribute the negatives to both terms and make sure that I get it. Now I do the antiderivative, and again, I don't trust myself, so I set 2 times. Alright? I think it's 8x over 1 minus 2x cubed over 3, evaluated from 0 to 2, plus, oh, deja vu, 2x cubed over 3, minus 8x over 1 from 2 to 3. Alright? Now, it's just plug and chug. You guys agree? Plug and chug, plug and chug. Alright, so here we go. Alright, I'm going to make the 2 black now. Alright, and I get 16 minus 2 times 8, 2 cubed is 8, times 2 is 16 thirds. And again, guys, I go very quickly through the math. You got to agree with that, right? Just like every college professor ever before me. Over there, the 3. 3 cubed is 27 times 2 is 54 thirds. Minus 24. Minus 2 cubed, 16 thirds. Minus 16. Alright. Alright. 2 times 48 minus 16, how about 32 thirds for this one right here, plus 54 divided by 3 is 18. So that's negative 6 minus, now let's distribute the negative. Alright, to negative 16 thirds and then plus 16. Ugh. 32 thirds minus 16 thirds. 16 thirds, negative 6 plus 16 plus 10, so that's 30 thirds. 30 plus that is 46 thirds. And assuming I didn't make a math mistake, which truthfully, doing this all in my head, might be a pretty big assumption. But I think I'm right. It's 92 thirds. And everybody, I would argue again, if you look at this, think about it, setting it up, is everything above the red line? And then grinding out the answer is everything below the red line. Again, the key to finding area, it's just the upper curve minus the lower curve, right? You pin the area in dx. The key to revolving a solid is doing volume equals area of the base times height. It's ax dx. And we're going to do that one next.